be talking about the man who figured out a shortcut for how to add the numbers 1 to 100. So this is going to be, if you saw my other video in arithmetic sequence, and this is described by 1, 2, 3, 4, dot to dot, all the way down to 100. And so the question at hand is, what do we get when we actually add all these up? Okay, so that's going to be the sum that we're trying to figure out. Well, if this is in arithmetic sequence, then that means that we have some kind of an A, which in this case is, of course, our first term, or 1, and they all have a common difference of D, which if you subtract any term from the term that precedes it, you can see they have a difference of 1, and any nth term can be described by A plus D times n minus 1. If you saw my other clip about this, then you would know what this is all about. If you haven't seen that other clip, go and look for it. So multiplying this out, this can also be represented by A plus dn minus D. So this is the general term for your nth term. And okay, so we're going to be interested to know how can we get the sum of this? Well, recall from my other video that if you have this summation from x equals 1 to n of A plus D to the x minus 1, that's the same as saying summation x equals 1 to n of A plus dx minus D. But notice how in this case we do actually know what our s based on n terms is for our s sub n, because we know that it's 100, so we can plug that in. So s sub 100 equals the summation of x equals 1 to 100 of our a term, or our first term is 1, plus our difference is 1 times x minus difference of 1. So the 1 times x doesn't do anything, and the 1 plus, or the plus and the minus 1 cancel out. So really we can't reduce this any further here. We're just going to be left with the question of the summation of these 100 terms from x equals 1 to 100 of x. And we're left with the question of how do we deal with this? Well, one day in the 1700s, there was a very young student at the time. He was about 7 or 8 years old, and if you've never heard of this name, Carl Friedrich Gauss. Actually, I could write out Gauss's full name for you. It's Johann Carl Friedrich Gauss. And if you haven't heard of this man yet, you will in your more advanced coursework, because the achievements that this man had were very impressive, and he touched a number of different fields like number theory, calculus, differential geometry, astronomy, optics. I mean, the accomplishments that he had were just incredible for his time. And he was born in 1777, for context. And the story goes that he was in class one day, and he was a young kid, about 7 or 8 years old, and the teacher gave this problem to the class, thinking that it would keep the class occupied, but actually the young Carl Friedrich Gauss noticed something incredible here, and he noticed and calculated it almost instantly that if you take our series 1, 2, 3, 4 all the way down to 100 again, he noticed that you can just make a bunch of pairs. To be precise, he noticed that you can make n divided by 2 pairs of n terms like this, given that you have an even amount of terms. Because if you had an uneven amount of terms, then you would have to account for the term in between all of them that did not have something to pair up with. So he noticed that if you take the first term minus, or first term plus the last term, here you're going to get 101. But he also noticed that if you go down for each pair here, then it's going to be the exact same sum all the way down. You're going to get n divided by 2 pairs of the quantity first term plus the last term. Or in other words, he noticed exactly what we just derived in the video before this one, of S n equals n divided by 2 of a plus, or times a plus L. So this was what he came up with, and when he plugged everything in, with n being 100, so the sum of 100 terms here equals 100 divided by 2 times first term is 1 plus the last term of 100. Then this is going to be 50 times 101, or 5050. It didn't take him that long to come to this conclusion, and everyone in his class and the teacher were absolutely astonished. And this is one of the early first, I guess, instances of his early brilliance. So hopefully you found this useful, and maybe you can impress your friends with this skill here. So I'll see you in the next one, and come back where Joe shows you how